divides 90 fourth graders into two groups.
Okay, so stop for 1 second. The keywords: randomly, 90, two groups. Excellent.
Group 1 is taught to use the new curriculum, while Group 2 is taught using the traditional curriculum. At the end of the school year, both groups are given the standardized tests and the mean scores are compared. Determine whether the sampling is dependent or independent. Indicate whether the response variable is qualitative or quantitative.
Okay, very similar to the previous one. Is it dependent or independent? She randomly divides 90 students into two groups. Group 1 gets the treatment, Group 2 gets the control. By control, we mean what we compare to. And that both groups are given the standardized test at the end, and the means are compared. So the sample is independent because the individuals selected from one sample do not dictate which individual. Absolutely. Well, everyone agrees?
Yes.
Thank you. Indicate whether the response variable is qualitative or quantitative. We have to go back and read. Standardized test, and the mean scores are compared.
E as well.
Quantitative because it is a numerical value. I didn't even read the other three. I trusted you fully, blindly. Okay, so we had 4 to 7, and we also had a remainder of 14. 14 was the last one we didn't do last time. Let me just go back for a second. I'm pretty sure we did 8, but maybe I missed something. Which of the following is not a condition to check when doing a two-temp? Okay. Yes, we did this one, but if you want to go back and look at it again, we can. Okay, no one said anything. That's fine. Okay, so let's go back to 14. Okay, can anyone start us on this one?
I can do it.
Thank you.
Since an instant replay system for tennis was introduced at a major tournament, men challenged 1,404 referee calls, with the result that 428 of the calls were overturned.
Now we have to stop right there. 1 second, 1 second. And I have to write down this information. And we get that men out of 1,404, 428. So this is the p hat for men right here, with the result that 428 of the calls were overturned. Okay, so this is the first sample for men, P1 hat. 428 were overturned out of a total of 1,404. Okay, back. Good. Sorry for interrupting, but we have to discuss every step. Okay, now women.
Women challenged 764 referee calls, and 223 of the calls were overturned.
Very good. So this is our P2 hat, or P hat 2. Better. P hat 2 or P2 hat, doesn't matter. So they challenged 764. And 223 out of 764 were overturned. And remember, the formula for p hat is always x divided by n. N is the sample size, and x is the number of successes, if you want. We are looking for how many they were overturned. Awesome. And now
use a 0.05
yes.
significance level to test the claim that men and women have equal success in challenging calls.
Okay, perfect. So this is alpha. Of course, P1 equals P2. And can anyone come up with the alternative?
Would the alternative be P1 does not equal P2?
Awesome, brilliant. Because we're not told if one tests the claim that one has more than the other, right? So we're testing that they are not equal. Excellent. Okay, now we go back And let's discuss this. Test the claim using a hypothesis test. Fine. Consider the first sample to be the sample of men. Fine. Okay. Who challenged, and the second to be the female. Fine. Find the null and the alternative. Can anyone help with this one? It will be C. Equal to, not equal to. And remember, this can be written, it's the same as you write P1 minus P2 equals 0, or P, and for the alternative, P1, minus P2 not equal 0. So this is the same with this. And these two are identical. Okay? Back. Okay. Identify the test statistic. Okay. So then we will go to, as you see, since Wednesday, I didn't calculate anything with this calculator. So now we go to stats, so we go to tests, and we have a 2 proportion Z test. We're talking about proportions, and this is a Z. So 6. X1, 428. N1, 1404. X2, 223. N2, 764. And we want not equal to for the alternative. Okay? Okay, P1 not equal P2. And as you know, I like to draw because I see the shaded area and I see the p-value. You don't have to, calculate is good enough, but I like my graph. And just make sure you don't have anything else in y equals. Sometimes it can. Okay. Good. Huge p-value. Wow. So Z, statistic, 0.6288. P-value, it's right here at the bottom, 0.5295. So back to the problem. Where is my problem? My problem is here. Z statistic round to 2 decimal places, 0.63. Okay, 0.63. And then the p-value, huge, round to 3 decimals, 0.530. 0.530. Yeah, I was typing in error. 0.530. Okay. Perfect. What is the conclusion? First of all, let's talk about the conclusion. Can anyone give us the conclusion here? So let me stop sharing for a second. We are comparing alpha to the p-value. What do we conclude?
So it's greater than alpha.
Is it fail to reject?
Thank you. Fail to reject. Because it means that the Z statistic is in the non-rejection region whenever p-value is smaller than alpha. Good, perfect. Let me share. Good. So p-value is, what should I choose here? The p-value is the significance level.
Greater than.
Of course. So we reject or fail to reject. You already told me. Correct. There. And now this is tricky. So you have to carefully read this, right? There is not enough evidence to warrant rejection of the claim that women and men have equal successes in challenging calls. So there is not We fail to reject. So the sample does not, there is not enough, there is not sufficient evidence coming from this sample. Maybe if I repeat the sample in 10 years from now or 5 years from now, that will be different. I don't know. But from this particular sample, there is not sufficient evidence to warrant the rejection of the claim that men and women have equal success. We cannot reject that. There is not sufficient evidence to reject that. And this completes our 11.1 with 1.6, with the independence and dependence, etc. Okay, back to, we have 2 more assignments to look at. We have 11.3 for the means and 11.3a. And that's the end of the course, so please finish up, including the chapter quiz. Bring to class all questions, anything you may have. So we completed this, now we are here. Good. So can anyone help us with this?
I can read it.
Please, thank you.
Define the phrase independent samples. What is the definition of independent samples? So, let me just read these really quick.
Sure.
Do you want me to read them out loud or?
It's up to you. If you want to. We love the way you read.
I would say it's A.
Correct. The sample selected from one of the populations has no bearing, no effect, no influence on the sample selected from the other population. That's exactly what independent samples means. Exactly. Thank you. Okay. Who would like to start this one? They're not different. The only difference is we are using the t-test instead of the z.
I can read it again if you
Thank you.
The primary concern for performing a hypothesis test to compare the means mu1 and mu2 of 2 populations is deciding whether the mean of population 1 differs from the mean of population 2. A. Determine the null and alternative hypotheses. Note, always place the mean of population 1 on the left. And B. Classify the hypotheses test as two-tailed, left-tailed, or right-tailed.
Good. Can anyone tell us what is the key word from everything that you see here? What is the key word?
Are you talking about to determine like A?
Yes.
I would say differs.
Exactly. That's it. That is the key word. Nothing else really has that much importance.
So then the null hypothesis would be mu1 equals mu2, and then the alternative would be it does not equal.
That's it. Brilliant. That's it. That's the key word in that sentence. Awesome. And now we know, based on the alternative, whether this is one-tailed test, two-tailed test.
Two-tailed?
Of course, two-tailed test. Great job. Thank you. Okay. Same thing, but now the keyword is greater. The null hypothesis, we know it's always the same. What about the alternative?
So then you just use the greater than sign.
Of course. That's the key word here. One-tailed test or two-tailed test?
One-tailed?
Yes. Left or right?
Is it right?
Excellent. Brilliant. Thank you. Good. Now it says the same thing with less than. Yes, we know less than. Yes, because we already discussed this over and over. We know it's a one-tailed test, but is it left or right?
Left.
Excellent. Thank you very much. Good. So let's see the table. Let's say accompanying table. Okay, so we have a table here. We may have to go back to it. Okay, so let's see what they want. Who would like to help with this one?
I can read it.
Please, thank you.
The accompanying table shows the technology output for a test using data on the pulse rates of several hundred people to see whether men or women tended to have higher pulse rates. Complete parts A and B below.
Good. So report the sample means. So when we look at here at this table, we have for female, the sample mean is 75.9. And for male, I'm just going to take notes because I may have to graph something or show you something. I don't know. We'll see in a moment. So X female bar 75.9 and X bar for men is 71.9. Okay. The women's sample mean pulse rate of, and we see it here, 75.9 was, and you'll tell me what to write in there. So this is 71.9.
Higher than?
Of course. Good. Good. So now let's continue. So we are using this output, technology output, for men and women are not equal. Using a significance level, so I'm writing, taking notes, okay, 0.05, which is 5%. The samples are large enough so that normality is not an issue. But we will be using the t statistic. Okay, so which of these 6 options we have for the null and for the alternative?
E.
Is it B?
So are not equal. For men and women are not equal. So you said E, perfect. Women not equal to men, and then women not equal to men. That's the key, right? Not equal. Perfect. Great job. And now let's continue. Where is it? Find the test statistic. They are giving us the test statistic. It's right here. It's not upper key t, it's just lower key t, and the t value is 4.27. So this is not the t value. It's the t statistic. Okay, so that is 4.27. I typed in the error again. Good. Now they want the p-value. It's right here. It says do not round, really. Okay, I will not round. Okay, so now let's draw a conclusion. So I'm going to stop sharing for a second. So this was alpha, and the p-value is this. And alpha is 0.05. What do we conclude? We have 2 possibilities. Say it again.
Sorry, so then since the p-value is less than alpha, then we reject the null hypothesis.
I wanted to write the other option, which is obviously incorrect, so you stopped me.